Hey guys, today we're going to learn how to solve linear systems by graphing. So a system of equation consists of two or more equations with the same variables. So in Algebra 1, we're going to focus on two equations, okay, with two different variables. So for the most of the time we use x and y. A solution to the system of equation is the ordered pair that satisfies both equations. So we're going to find out that there's three possible solutions. We can either have one solution being the ordered pair, or there's no solution because the lines do not intersect because they're parallel, or there's infinite solutions because the lines are the same. The steps to solving a linear system by graphing, I'm going to start out by first just graphing the two lines. Okay, so if you notice with example number 1, it's pretty easy because we're already in slope-intercept form, y equals mx plus b. Okay, so using your knowledge of graphing lines, we start at the y-intercept for the first one, which is 1, and our slope is 1. So rise 1 over 1, and it's going to look something like this. Okay, so the equation of the first line, or the graph of the first line, is going to look like this. Okay, now the second line, all right, y is equal to negative x plus 3. We start at the y-intercept of 3, 1, 2, 3. And this time we have a negative slope, negative 1 slope. So we're going to actually have a line going down like this. Okay? So you can tell that the intersecting point here would be right here at the ordered pair 1, 2. Okay? So that would be our solution. In this case, it's just one answer. We're just intersect at one point. Okay? But we can always do a check step to make sure. All right, so our check step, we take the point 1, 2, and we plug it into the first equation. So your y, which is 2, is equal to 1 plus 1. Well, does that work? Yes, it does. Okay, then you plug it into the second equation right here, and we've got y, which is 2, is equal to negative x, negative 1 plus 3. Does that work? Yes, it does. So because it satisfies both of these equations, we know that 1, 2 is the solution. Okay, so why don't you guys pause right now and just try number 2 for me. Okay, now that we're back, okay, if we graph number 2, we've got y is equal to x plus 4. So we're going to start at the y-intercept of 4, 1, 2, 3, 4, and our slope is a positive 1. Okay, so our line is going to look like this. Okay, and our second line, we've got a y-intercept of 5, 1, 2, 3, 4, 5, and in this case our slope is 2. We're going to rise 2 over 1, or we could go down 2 over 1, down 2 over 1. And you've got to be really careful with these. I suggest definitely using a ruler to make sure that your lines are straight. Okay, if you look at this one, we intersect right here at the value negative 1, 1, 2, 3. So it looks like it's at negative 1 and 3. Okay, so that would be our solution. But now let's do our check step. We take that point, negative 1, 3, and plug it in. Y is 3 equals negative 1 plus 4. Does that work? Yep, 3 is equal to 3. So the first one works. And you have to do the check step for both equations. Okay, y is 3, and that's going to be equal to 2 times negative 1 plus 5. Okay, 3 is equal to negative 2 plus 5. And it looks like that one works as well. Okay, so always do your check step to verify the answer. Okay, so the first two examples were pretty easy. They were both already in slope-intercept form. So if you look at number 3, it's not always going to be that way. So we've got a first step is to put it into slope-intercept form, and you should be pretty good at this by now. So the first one would be y is equal to negative x plus 5. All I did was bring the x to the other side by subtracting. Okay, so when I get my y-intercept, it's 1, 2, 3, 4, 5, and in this case, my slope is a negative 1. Okay, here we go. We go down like this. Okay, and now the second one, when I bring the 2x to the other side, y is equal to negative 2x plus 8. Okay, this time our y-intercept is 8, so 1, 2, 3, 4, 5, 6, 7, 8, and our slope is negative 2, so I'm going to go down 2 to the right 1, or up 2 to the left 1, down 2 to the right 1, down 2 to the right 1. So it looks like I'm going to intersect right here at 1, 2, 3, 2. So the point that I intersect is at 3, 2. All right, and I'm going to check it. So my check step, my x is 2, my y is 3. 2 plus 3 is 5. Yep, that one works. Okay, then the second one I'm going to check, it's going to be 2 times my x, so 2 times 2 plus 3 is going to be equal to, it's going to be equal to, did I erase that? Let me see, should be equal to 8. Okay, my y is, actually I did that one wrong. Let me erase that for a second. Okay, so that one, my x is 3, so 2 times 3 plus 2, does that equal 8? Yep, 6 plus 2 is equal to 8. So my check step worked for that one. So we have a number of examples here for you, 4, 5, 6. I want you to go through and check them with the answer key. That's also published on Student View, but I wanted to take the time in the video to show you a couple of the special cases. So if you look at the example, let's jump all the way to number 9 for this one right now. If I jump to number 9, okay, y is equal to 2x plus 3. So my 1, 2, 3, I'm going to start graphing this. My slope is 2, so I can go up 2 to the right one, or I could go down 2 to the left one. Okay, and so I'm going to graph my down 2. Okay, so I'm going to graph my line. This looks like this. Okay, and then the second one I've got to put in slope-intercept form. So I've got 2y is equal to 4x minus 8, and when I divide both sides by 2, I end up with y is equal to 2x minus 4. Okay, so if you notice 1, 2, 3, 4, now with my slope of 2, these two lines are actually going to run parallel to each other. So it's going to look like this. Okay, now if your two lines run parallel to each other, they're never going to intersect. So there's actually no solution. All right, they'll go on and on forever and they will never intersect. So no solution. Okay, now number 10, when we do number 10, we've got to put it in slope-intercept form. So we've got negative y is equal to negative 3x minus 3, or we could say y is equal to 3x plus 3 when we divide both sides by negative 1. Okay, so I'm going to start with my y-intercept of 3, and my slope is positive 3x, positive 3 rather, so I'm going to go up 3 to the right one, down 3 to the right one. Okay, it's going to look like this. Okay, now the next line, looking at the equation, I am going to put it in slope-intercept form. Okay, so to do that, I've got my negative 2y is going to be equal, I'm going to bring the 6x to the other side, so negative 6x minus 6. And then when I divide both sides by negative 2, okay, I'm going to do this, I end up with y is equal to 3x plus 3. So if you notice, these are both the same line. So when I graph them, they're right on top of each other. That means that every single point is an intersecting point. So this would be the solution of infinite solutions. Okay, not all real numbers, because we're not getting all real numbers. We actually have an infinite number of solutions. Okay, so moving on, I'm going to look at 11 and 12. It says, a solution to a system of equations is the ordered pair that satisfies both equations. So if you have the question, is 0, negative 2 a solution to the following systems? And sometimes with systems you might see a little curly bracket here. Okay, I just don't want you to get confused by it. All you have to do is take that ordered pair, your x and your y, and plug it into both of those equations. If they're true for both, then it is a solution. So my x is 0 for the first one, minus 2 times negative 2 is my y. Does that equal 4? 0 plus 4, does that equal 4? Yep, so it works for the first one, but remember, you have to check it for both. Okay, so now when I check the second one, I've got my y is negative 2 minus 0, does that equal negative 2? Okay, I'm just looking right here at this equation. So negative 2, does that equal negative 2? Yep, it works for that one. So to answer the question, is 0, negative 2 a solution to the following system of equations? The answer is yes. Okay, so we'll do the same thing for number 12. If you want to pause the video right here and try it, you can. But if you plug in 2, 6, okay, 6 is equal to 3 times 2 minus 3. Okay, 6 is equal to 6 minus 3. Well, does 6 equal 3? No. So as long as one of those does not satisfy the system, as the solution, then you can write no. Okay, you don't even have to check both of them. All right, and then finally, number 13, it says, what is the solution to the following system of equations? Well, this is actually very easy. It's really checking to understand that you understand that a solution is the intersecting point. So the solution to the following system would be the ordered pair 1, 3. There's your answer. You don't need to figure out the equations of the lines. All you need to do is identify the ordered pair. Okay, so there's a number of problems in this packet that you can go ahead and practice, okay, 14, 15, and 16, okay, and then I want you to go back to the key that's on Student View and just make sure that you're doing them correctly, okay. So I'm going to pause the video right here and have you guys try it. So again, check your answer with the answer key.